Differences between linear regression and logistic regression. Linear regression versus logistic regression. The data is modeled using a straight line in linear regression, whereas the probability of some obtained event is represented as a linear function of a combination of predictor variables in logistic regression. Linear regression is used to predict the continuous dependent variable using a given set of independent variables, whereas logistic regression is used to predict the categorical dependent variable using a given set of independent variables. Linear regression is used for solving regression problem, whereas logistic regression is used for solving classification problems. In linear regression, we predict the value of continuous variables, whereas in logistic regression, we predict the values of categorical variables. In linear regression, we find the best fit line, by which we can easily predict output, whereas in logistic regression, we find the S-curve by which we can classify the samples. Least square estimation method is used for estimation of accuracy, whereas maximum likelihood estimation method is used for estimation of accuracy. The output for linear regression must be a continuous value such as price, age, weight, etc., whereas the output of logistic regression must be a binary value such as 0 or 1. Linear regression are used in business domain, forecasting, econometric modeling, marketing mix models, customer lifetime value, etc. Logistic regression are used in classification, image processing, customer choice model, click-through rate, conversion rate, credit scoring, etc. In linear regression, accuracy is measured using least square method, whereas in logistic regression, accuracy is measured using maximum likelihood estimation, which is based on a method of estimating the parameters of an assumed probability distribution, given some observed data. In linear regression, it is required that relationship between dependent variable and independent variable must be linear, whereas in logistic regression, it is not required to have the linear relationship between dependent and independent variable. In linear regression, there may be collinearity between the independent variables, whereas in logistic regression, there should not be collinearity between the independent variable. Sample model of linear regression and logistic regression are given. The cost function of a linear regression is root mean squared error, or also known as mean squared error, MSE, which measures the average squared difference between an observation's actual and predicted values. The cost will be outputted as a single number which is associated with our current set of weights. The reason we use cost function is to improve the accuracy of the model. Minimizing MSE does this. The formula of MSE is given. Whereas in logistic regression, the weighted sum of inputs is passed through an activation function called sigmoid function, which maps values between 0 or 1. The formula of sigmoid function is given. The cost function of a logistic regression cannot use MSE because our prediction function is non-linear, due to sigmoid transform. Therefore, we use a cost function called cross-entropy, also known as log loss. Cross-entropy measures the difference between two probability distributions for a given random variable or set of events. The formula of cross-entropy is given. Using linear regression, you can plot the graph of sales versus advertising and find the line of best fit between them, and, using that, find the values of the missing variables. Whereas, suppose you have credit card numbers and their transaction history. You want to classify credit cards as fraudulent and legitimate. You can do this with logistic regression. Kindly subscribe my YouTube channel Thesis Helper. Thanks for watching.